it's a pure substance. And since it's a pure substance, what is it?
An element.
It's an element. Tell us what it is.
I got
Oh, a lady should always know that. Okay, what is it?
Is it a pure substance?
Yeah, she's got this part just fine. It's a pure substance,
can't
it's
be
an
round.
element, but
Gold.
AU.
Gold.
Gold. Okay? Now, toss that to somebody. Oh, watch out. Be sure they're looking at it. Don't just toss it around. Sorry, Brittany. Okay, we have this stuff right here, Brittany. So, pure substance or mixture? First mixture. Okay, is it? Remember the dot is a dirty, dirty trick? And that's actually a part of the formula. There were 3 tricks in formula writing. There's parentheses as a trick. There's no ones written as a trick. The other trick was the dot, meaning water of hydration, actually trapped in the crystals, part of the substance. I put this up here intentionally because I know this one is misleading. So, would you like to change pure substance? And if it's a pure substance, then what have we got?
Compound?
Okay, exactly. We have a compound. If I abbreviate that much, everybody can follow that, right? Okay. Meet somebody's eyes and toss it gently to them. If nobody, okay, or hand it off. Andrew, fruit salad.
It's a mixture.
It's a mixture.
It's homogeneous.
Well, let me describe it.
Okay.
Okay, you're in Luby's or wherever, and it's like pieces of apple and grapes and maybe some kiwi fruit, just chunks of stuff.
So then
Heterogeneous, because what do you mean when you say heterogeneous?
it's all different.
Yeah, to your
Yeah,
eye,
yes.
you can see different pieces. I mean, you can say, that's apple, I despise apple, and you can pick it out of there and not eat it. Okay? So, it's going to be a heterogeneous mixture. What could we do maybe to turn that into a homogeneous mixture? Use a blender. Use a blender. Here's a really disgusting story. I used to work briefly in pathology, okay? And when I would eat lunch, I would look at the journals, which sometimes had ads in them. And there was this ad, I couldn't believe this. This is years ago now. They may do things a little differently, but they had this ad for the mouse homogenizer. Let your imagination wander. Okay, so they have a picture of a mouse, and then they show the mouse after he has been through the homogenizer. Looked like a chocolate malt. Okay, and was the same throughout. Now, that is not just for torture, although I'm sure it is. It's not just for torture. If you're testing some drug, and you just want to see how much was absorbed by the entire body, you know, not just, let's say, in the liver or something specific you could take out and analyze it. You just want to see how much is absorbed in the entire body, if that's the way to do it. Later on, I was at chemistry talks in Nebraska, out in the middle of nowhere in central and western Nebraska. They had at this slaughterhouse cow homogenizers, big scale. And again, it was the Food and Drug Administration testing, you know, whatever the drug, you know, they talked about feeding cattle antibiotics and is that good for us or not, how much was absorbed in this total cow. Okay, interesting concept. But homogeneous and heterogeneous. I mean, you can change one to the other, like with food, with a homogenizer. All right. Then let's toss gently to hand off or toss. Okay, Bruce is bright.
It's a mixture and it's homogeneous.
Okay, it is a mixture and it is homogeneous. Or you want it to be. If you see lumps,
Yes.
you would get very suspicious and probably not eat it.
Correct.
Okay, one time, again, I love disgusting stories. There was a machine over in the ad building and it would dispense hot chocolate. Similar, you know, chocolate milk that is hot. Okay, so I take my cup and I was taking a night class, a Spanish class. Okay, so I take a sip and I feel a lump on my lip. I think, isn't that nice? They put marshmallows. Wrong, it was a dead roach. And then I discovered it was a dead roach, because you know the little tube coming down, aiming at your cup, anything can run up it. And so I ran for the bathroom. I did a whole bunch of spitting and washing out my mouth. But anyway, the hot chocolate or hot, chocolate milk should be homogeneous. If there's lumps in it, get suspicious. All right, now let's go over to this part. We're going to switch and talk about chemical and physical changes. We've talked about the properties. We've talked about the changes. Bruce, hand off. Marco, you're up.
All right.
Okay, I fed my cats tuna this morning. They're probably sitting home sleeping right now, and that tuna is digesting. What kind of a change is happening in their little bodies? Chemical. Because remember, chemical changes are destructive. I'm never going to get the tuna back. Now, I will get something in return, but it's not going to be tuna. Okay, so that digestion is a chemical process, or photosynthesis, chemical process. Okay, pass off. Okay, you're up. Russell, you're up. Silver melts.
Physical.
Physical. Remember, any phase change is physical, because you melt that silver, you still have silver. I mean, you've got pure silver, and you would like to turn it into a ring or something. Okay, you can melt it and then form it into the way you want it. And then, calcium carbonate, pass off. Did you pass off, Russell? Okay, Pedro, you're up. Calcium carbonate, which is chalk, just ordinary chalk. It also can be used in antacid, antacids that we sometimes take. Okay, you put it in water and you get some to dissolve at a high temperature, and as you cool the water, it starts precipitating out. Now, I've learned over the years, you hear the word in everyday life, precipitation. The weatherman says there will be precipitation today. That means it's going to rain or snow or do something. It's falling out of the sky. So we think of precipitation in everyday life only as rain. Okay, that's not true. Precipitation is when a solid comes out of a solution for us. It is precipitating out. So it's still something falling, but it's a solid coming out of a solution. So, Pedro, did that give you enough time to think?
Physical.
Physical. It was calcium carbonate when it was dissolved, and when it comes out, it's still calcium carbonate. Okay. Flow of heat, like you put a stove on you put a pan on the stove, and Antonio, hit it.
Chemical?
Okay, did you destroy your pan?
No.
Did you destroy your stove?
Just kidding.
What? Good recovery. I've never heard anybody say that before. Okay, so it must be physical, non-destructive. Okay, now, pass off, Antonio. Okay, Clint, you got it? Flow of electricity through your house through the copper wire.
Physical.
Physical. Okay? Because it doesn't destroy your copper wire. Hopefully it doesn't destroy your house, doesn't cause a fire, have a short or something. Yeah.
Okay, this is the stuff that confuses me. So anytime it's destroyed, it's chemical.
Okay, yep. Yep. Now, sometimes that's hard. If something's precipitating out, I guess you've destroyed your solution, but the chemical composition of the junk doesn't change.
Okay, because that's confusing because of the flow of heat, the stove, the pan. I thought chemical because of burning. So
Okay, but you're talking about your ability to cook or not cook. Okay, that you've got something in the pan, something that is inside the pan. That's a good point she's made, because I was just thinking the heat from the stove to the pan, getting the pan warm, and I was not thinking of the substance inside. The substance inside, you may want a chemical change to take place, or you may just be melting some butter and you just want a physical change taking place. So there could be something more going on. Okay, but here I just mean heat from the stove to the pan, end of story. Okay?
Yeah, I was also wondering why, I thought it was a chemical because it was taking oxygen, and it was taking water out of
okay, I'm thinking electric stove.
No, I'm talking about C.
C.
Okay.
Okay, let me go back though, because you brought up a point here. If you've got a gas stove, Okay, what you might be thinking, you know, you turn on the gas, you light it, yeah, producing that heat in a gas stove, that's a chemical change going on. You're using up the gas and using up some oxygen. I'm just thinking electrical stove, you know,
Yeah.
it's just getting hot, the pan
Yeah,
gets hot.
yeah,
Okay, now
yeah.
let's come down to your real question.
No, see,
See, here,
I was wondering why, because I thought if you're taking water out of it, would you also take oxygen
No.
from the CaCO2?
no. Not in that case. See, you've got some junk that's just dissolved. Okay, let me make it.
Like salt water?
Okay, yeah, okay, or you like coffee with a load of sugar. So you put sugar, you put sugar, you put sugar, and you stir and you stir and stir, and the coffee's hot, and it dissolves quite a bit of sugar. Well, you're studying and you set your coffee aside, and it starts cooling down before you drink it all. Some of that sugar could start precipitating out, and you have some solid sugar at the bottom. So that would just be physical, okay? It was sugar, you know, dissolved up, and then it starts precipitating out. So here, this is
That was
calcium.
like your salt water example.
Yeah,
Okay.
the salt water, yeah, you get that, it'll start precipitating out when you remove enough of the water, yeah. Brittany, did
I
you
was
have?
gonna say, is it like tea, like the same thing, like sugar and then like.
Sugar in the
it's
tea,
the-
yeah.
Okay.
Like, you have tea, let's say you take a cube of sugar, or a teaspoon of sugar, whatever you want to do. You stir and you stir and stir, and it will dissolve. That is a physical change, dissolving is physical, okay? If it cooled way down, I could see if you'd really put a load of sugar, the sugars could start precipitating out. You could reach the solubility limits at that lower temperature, because more junk dissolves at a higher temperature.
Okay, I was
General,
saying like, you know,
general.
like cold, like the cold tea and like, I feel like a long time it's at the bottom.
Okay, but it's
Be the
still
same
just
thing.
sugar coming out, right?
Okay, so it's the same thing, okay.
I do was thinking about the electric, and if you have a short in your electricity, then that would be considered a chemical change?
Probably what would happen, you could have a short, which then could heat something up, and yeah, your house starts burning down, you got trouble, yeah.
But
It could,
because
but
you're
you
gonna be
want,
really specific
I
about
will
what you.
try to be. You can
Okay.
always, you can raise your hand and say, do you mean
Okay.
da-da-da-da-da-da, and
You
I
can
can
say
answer
yes or
or
no.
not answer, you know, depending upon,
How we put it.
yeah, how you put it. It's like, every time I walk in the kitchen, my cats always come running in asking for food. Sometimes they get it, sometimes they don't. But, you know, I don't kick them, you know, it doesn't hurt them to ask, so they're asking all the time. And sometimes it's yes, and sometimes, you know, so questions on a test, you know, if you'll say, AU, tell me what AU is, well, I'm gonna go, you should know that. But if you ask me something like, do you mean the food in the pan, or do you mean just the heat and the
Or
pan?
the water.
Yeah, exactly, yeah.
Could you go through another chemical change, just one that's not up there, something off
A
the wall
chemical
different? Another example of
Okay.
something,
Let me see. Well, any sort of burning
okay,
is going to be chemical. The silver is tarnishing,
okay. So
okay?
it goes back to
That's a
the-
chemical change. Now, that's, you know, when you say it's a change, it doesn't have to be a fast change.
Like lush seeds or something, basically
Yeah.
the same thing we wrote,
Yeah,
okay.
yeah. Okay, or chemical changes as you age can happen to your skin. You know, the DNA can go wacko and you've got skin cancer.
Your hair.
Yeah, exactly.